Hi there. Hi there, it's Veronica Madrona. I'm here to talk about my project, which is trying to detect mental disorders in tweets. For this project, I used an existing program which detected sentiment in a political campaign and made the necessary tweaks. For any major sentiment analysis problem, you need to understand the problem, pre-process your tweets and clean them up, tell a story and visualize them, and extract features, so turn the words into a vectorized form that the computer can understand, and build your model out of that. So here I'm importing my machine learning libraries, loading the training data set. The challenge was actually finding that due to ethical concerns I had for people's privacy, but luckily Stanford had a publicly available one with pre-generated labels. So I analyzed this and could see it's a good training data set, equally distributed, expected word count for a tweet. And then I decided to use Twitter's API for future data. You can also do web scraping on Twint. I found that the API was more convenient at the time because the research showed that I could query for multiple terms. But I found out later that you could do that with Twint too, so they're both good. So here you can see I queried for terms depressed, anxiety, excited and hopeless, and numb. I wanted to include a neutralizing term, excited, just to see how the model would, if it would predict that to be what is expected also. So I built my data frame out of this set. And you can see, also the location of the tweets. Save the data frame to a pickle object. I clean them up using a function here. And then you can see they're much cleaner. Get a word count. You can see depressed and anxiety show up as well as excited. And a major, actually, big difference in this project was that I actually included first pronouns, I, my, me, myself, in the stop words, because it's found that depressed people use these terms a lot. But in the research I was doing, most of these sentiment analysis problems omitted those out of the list. And then I, analyze the tweets more after that. Then I, do the word clouds here, visualize it. You see excited shows up quite big there, and then anxiety and depressed. So I could probably explore more ways to query the future data. Then I turn the data into vectors using common models for text processing, bag of words, TF-IDF, and word2vec. I want to explore word2vec more. It's seems interesting and more advanced, such that you look at the surrounding text to predict, what a certain word might mean. Like here, I do a little bit of exploring there by seeing what's the opposite of depressed. So there's different ways you could, extract the features. Then I use model building, and I decided to use sklearn's pipeline, which is this great utility where you could do a lot of things at once, like load up your feature extraction tools and your classifier and optimize at the same time. You see the grid search CV and using a tenfold cross-validation there. And I wanted to use more models, but I didn't have time. So with the naive Bayes, I get an accuracy score of 0.743. And then, I'm making some predictions here. So you could see it's kind of a mixed bag in conclusion. But there are some expected results. So you see excited shows up for 1. And then you see there's one that says depressed 0. So for next step, I want to experiment with more models to see if the predictions are better. Maybe look into how I can enhance the text processing and feature extraction. And maybe explore emojis more. And also maybe have multi-class labels like a neutralized state. And for longer term, it would be interesting to have supportive chatbots to help people out that could be having a disorder real time, maybe using Twitter's streaming API. Thank you very much.